Now let's look at the present value. If we know the future value, can we calculate the present value? That is opposite of the future value calculation process. So recall in the last video, we talked about the calculation of future value. We talked about the process of compounding. Here, to calculate present value, we use a process called discounting. So we are actually looking at the same formula. Recall that in the last video, we talked about future value equals to present value divided by 1 plus I. So then if we just rearrange that formula, we get the present value now equals to future value divided by, not multiplying, but divided by 1 plus I. So that is to calculate the present value. So if we know that we can deposit some money into a bank and make 5% interest rates, and we want $105 in 1 year, so how much do we have to deposit today so that we can get 105 in 1 year based on the 5% interest rate? Now, according to this calculation, we need $100. So now, if you recall, at the beginning of this chapter, we talk about how we want to capture the difference that time makes. So now think about it. 105 in 1 year is not the same as 105 today. It's actually only worth 100 today. So there is a $5 difference. And that $5 difference is based on $100 principal, or say the size of the cash flow. 1 year, we're only talking about 1 year here, and a 5% rate of return. So this process is called discounting, and discounting simply is to get the present value based on the future value. And if we are talking about more than 1 year, or say having a multiple period, then the present value is the future value divided by 1 plus I at the power of n. You remember in the last video we talked about future value being the present value multiplying by 1 plus I at the power of n. So you understand these two are the same equation, just written in different ways. So if we have $100, we can only have it 5 years in the future. How much would those $100 be worth of today? If it takes 5 years to receive $100, based on 5% interest rate and 5 years, the discounting process here tells us it's only worth $78.35. So the present value of the $100 in 5 years is $78.35 as of today. We can also try to use the financial calculator. And again, if you don't know how to use your financial calculator, check out my calculator demonstration videos. Now assume that you know how to use your financial calculator. Let's just say to calculate the present value, we just need to input 5 as number of years, 5 as the interest rate, $100 future value, and then compute for the present value. The calculator will give you a result of $78.35, which is consistent with what you have here. Now, here, your result from the calculator will be a negative number, but that's totally fine. That is just the calculator's way of differentiating the cash inflow versus outflow. So here, if you invest $78.35 in 5 years, you can receive $100. What if the interest rate each every year is different? Well, then we just have to discount each every year differently, or say separately. So here, your present value will be your future value divided by 1 plus I, while I being different interest rate each every year. So for example, if you can have $2,500 at the end of third year, or say 3 years later, each every year your interest rate is this much. What is the present value? Present value will be future value discounted by all these different interest rates year by year, and the result is about $1,900. And you can also say if you invest this much today, based on 7% interest rate in year 1, 8% in year 2, 8.5% in year 3, you can receive $2,500 after 3 years. So far we have been looking at this same equation to either solve for the future value or to solve for the present value. So if you know the future value, you can solve for the present value. If you know the present value, you can solve for the future value. If you look at your financial calculator, you realize basically we have 5 variables in the so-called time value of money calculations, right? So N is for the number of years, I or IY is for the interest rate, present value, payment, and future value. Also in this chapter, basically the PMT, the payment, will be 0 since we are only talking about a single cash flow. Later in chapter 5, we will use the PMT a lot when we talk about the annuities. We can actually solve for any one of these five variables if we know the value of the other 4 variables. You can actually do it with the calculator or solve the unknown variable manually based on the equation. Now let's look at an example to solve for the interest rate. If we bought a coin for $3.50 3 years ago, and then today we can sell for $4.75. So the idea is your investment of $3.50 can grow into $4.75 in 3 years. What is this growth rate? Or say what is the rate of return every year that you can earn from this investment? To calculate that, we can set it up in the calculator. We tell the calculator that it takes 3 years, and initially it's $3.50, and then after 3 years we will have $7.45. So we are trying to solve for the interest rate. The interest rate result will be 10.716, and that is actually telling you the interest rate, or say the annual return, is 10.72%. Okay, the calculator will not give you the percent, but you know this is a number in percentage. You do notice here for the present value we enter a negative $3.50, while the future value is a positive $4.75. So what if you forgot to put the negative sign here for the present value? Your calculator then actually will give you an error message. Okay, so between these two numbers, present value and future value, if you have to enter both, make sure one is negative, the other one is positive. It doesn't really matter which one is positive, which one is negative. Just between these two, one is negative, one is positive. You can also try by yourself. If you put PV as $3.50 and future value as negative $4.75, you should get the same result. So again, this is to solve for the interest rate if you know both the present value and the future value and how long it takes. We can also solve for the time, or say how long would it take for your present value to grow into the future value. We can also use the financial calculator. So with the financial calculator, if we want to invest $5,000 and double the money, which means we want $10,000, and if the interest rate we can get, or say the rate of return we can get, is 9 years. So how long would it take for my $5,000 investment to grow into $10,000 future value? The answer is 8, a little bit more than 8 years. So again, you enter these numbers into the calculator and you solve for n, and will be a little bit over 8. Again, one negative, one positive here. To summarize the whole chapter 4, I would say the whole chapter 4 is mainly based on this one equation, that future value equals to present value multiplied by 1 plus I at the power of n. Sometimes n is 1, so that's when we talk about only 1 year. But sometimes n would be 2 or 5 or 10. That's when we talk about multiple years. So sometimes we can try to solve for the future value if we know present value, interest rate, and number of years. We can also try to solve for the present value if we know the future value and then divide it by 1 plus I at the power of n. We can also solve for the I if we know the future value and present value and the number of years. We can also try to solve for the N if we know the future value, present value, and the interest rate. So this is the main part of chapter 4, and this is an introduction to the time value of money. In the next chapter, we'll extend this to capture the time value of money of not just one, but multiple cash flows. As a last remark, I highly recommend you to try practice all the calculations that I have included in this lecture and make sure that you can get the right results. And also try the practice questions that I set up on the textbook website. Time value of money may be a new subject for a lot of the students, so a good or efficient way to get familiar with the concept and the calculation is simply practice, practice, and practice.